Okay, so let's just recap what you did here. This problem basically was a two-part problem that required us to first do a conversion to determine the moles of oxygen. As soon as we had the moles of oxygen, we were then able to use the ideal gas law, as that only left us with one unknown. And so the ideal gas law then was the last step, and we converted to the volume of oxygen. Now let's take a look at the second type of Stoich problem that you'll see involving the ideal gas law. And go ahead and put me on pause and jot this down into your notes. And the question is asking what mass of zinc is needed to make zero point 0.6 liters of hydrogen gas at 25 degrees Celsius and 0.82 atmospheres. Now, right off the bat, you can see with this pressure, it is not at standard temperature and pressure. It is not at STP. I also noticed that they give us a balanced chemical equation. Don't forget that is key and fundamental to doing these types of problems. You need a balanced reaction. As always, I'm going to implore you to pull out your information into a list of givens. And when you do that, what you should notice here is slightly different from the last problem. This one is only giving us one unknown. I know my pressure, I know my volume, I know my gas constant, and I know the temperature. So in this particular case, I need to solve for N, at which point you should always just convert to Celsius to Kelvin first. Then, because, one more time, you guys, you're going to use Pivnert first in this problem. And the reason is because you are given only one unknown. You can take Pivnert and rearrange it to solve for moles, which is exactly what you need to do here. And again, I've shown that work to get N all by itself, or the number of moles all by itself. You're going to divide both sides of the ideal gas law by RT. And so here at the bottom of the slide would be the equation you're going to use to solve for the number of moles. And so here in that step, you can see that's exactly what we did. We just plugged in each of these values. Don't forget to cross-cancel your units. If you are solving for moles, can you take a guess what unit you should have remaining? That's right, every unit but moles should cancel. And that is precisely what happens here. And so now I am given 0.020 moles of hydrogen. Now, one big thing that you should understand is you are not done. The question was asking, what mass of zinc are you going to need? Okay, and check this out. You guys just determined the quantity of moles of hydrogen you needed. Can you think of what we are going to do next? Can you take a guess on how we're going to get from moles of hydrogen, the thing we just solved for, to grams of zinc? That's right, we're going to do a conversion. So now in this particular problem, you're going to set up your railroad tracks as the second part of the problem. And you're going to go ahead and convert from moles of hydrogen to grams of zinc. In the slide below, you can see here that I started off my problem with what we knew, or what we just calculated, and that was 0.020 moles of hydrogen. And my goal is to go to grams of zinc. And so I'm going to set up a railroad track and look at what goes in this middle railroad track that I'm highlighting here. 1 mole of hydrogen to 1 mole of zinc. Can you take a guess where we got that from? That's right. This is the part in chemistry of stoichiometry where we can take and use the coefficients from the balanced chemical equation as a conversion factor for allow us to convert from moles of hydrogen to moles of zinc. And so these ones right here, you guys, they came from the balanced reaction. There's a 1 here in front of the hydrogen, and consequently there is a 1 here in front of the zinc. Now, when we get to the moles of zinc, we need to now just do a simple conversion to grams by using molar mass. Don't forget to cancel your moles, and grams is what remains. And when you do the calculation, you should get 1.3 grams of zinc. All right, you guys, I hope you were able to see the two different ways that we are going to use stoichiometry and the ideal gas law. Thank you so much for tuning in.